video this because I haven't talked about this. You're the first group that's had this information. So here we go. We're going to talk about composition again. We did this before lunch, right? That notation, everybody knows what that means. Read this to me. How would you read that, Katie? There you go. F of G of X. Every other word is an F of G of X. So we said what this meant, and in a minute we're going to do it in the other order. What this means is find F of X squared, right? Would you agree with that? And so that would be F of X squared would be what? If you take this and plug it in here, what will it be? The square root of X squared plus 3. And when we have a plus in there, we do not take the square root of anything. That's it. That's your answer. Okay? What?
You said if we have a plus in there.
Or a minus. Yep, under a radical, you can't do anything. Now, let's come over and do this one, then we're going to answer these domain questions. This one says G of F of X. So that means we're going to find G of the square root of X plus 3. So that means, here's my G function. That means I'm going to take the square root of X plus 3 and plug it in right here. So I'm going to get the square root of X plus 3 squared, which is just X plus 3. I'm taking this function and plugging it in here. All this function does is square whatever you plug in. So if I plug in that, I just get X plus 3 out of it. Okay, now, I want to talk about domain. Because a lot of times the question will be after you've done the problem. So this is the answer you got. The question will be, what is the domain of the composition? What is the domain of the composition? And sometimes you never can look at just this. When someone wants to know the domain of the composition, you have to find the domain of the input. So the original input, which in this case would be G, and the domain of the answer, and then put them together and find out where they overlap. And that's the answer, okay? So you can't ever just look at this. You have to look at your input variable, which is G. Okay, let's look at this function. What's the domain of that function? All real numbers. Then look at the domain of the composition you got, which is this. Now remember, when there's a radical, your little domain antenna are going up, right? You can't be negative. Well, this is a special problem. Is there any way that's going to be negative? No. So what's the domain of this? All real numbers. And so the answer to the question, what is the domain of the composition? It's all real numbers. So let's come over here. The question says, literally in your textbook, it says, here's F, here's G. Find F of G of X, G of F of X, and tell the domain of the compositions. Okay. To tell the domain of a composition, you have to consider input and final answer. So the input is the F function this time. That's what you input first, the F function. What's the domain of the F function? Now look, it's under a radical, so be careful. What's the domain of that function? X has to be bigger than or equal to, well, X plus 3 has to be bigger than or equal to 0, which means X itself must be bigger than or equal to -3. I know exactly who's watched the 1-2 video and who hasn't. You guys, there is a lot of information in that video and you need to watch it. It walks you through this. Whatever is under the radical must be positive. So x has to be bigger than or equal to -3. Now, look at the final answer. What's the domain of that? X plus 3. No. The domain is everything. There's nothing x can't be. When do my domain radar go up, people? When there's a square root and when there is a fraction. Because I can't have a 0 in the denominator. If I have no radical and no square root, then I have no problem. Except for weird things like logarithms and stuff. But in normal problems, no radical, no fraction, no issues. No radical, no fraction, no issues. The domain of that is all real numbers. Now, when you give me the final answer, what is the domain of the composition? You must put these two together. What numbers are going to satisfy both of these domains? Just the numbers bigger than or equal to -3. Think about this for a minute. In order to make this happen, we had to go through this step first, right? And the only numbers that you can put into step 1 are numbers bigger than or equal to -3. So therefore, nothing else is going to matter. It looks like we're a little lost. Let's do this other example. I'll have to recopy it over here. What are they? 1 over x minus 2 and x squared. Okay, so we're going to build this composition. I don't know what I wrote over there, but we're going to build this one, okay? So that means f of x squared, g of x is x squared. And what would f of x squared be? Now put x squared into your f function. What do you end up with? 1 over x squared minus 2. Agree with that? Okay, now let's talk about domain. This is the composition I built. So I must consider the domain of my input function. This was my input function, my original input. What's the domain of G? All real numbers. I'm going to say it one more time, and then I want you to go home and watch the stupid video. Okay? No radical, no fraction, no issue. This does not have a radical, it does not have a fraction, therefore its domain is all real numbers. Now, look at the answer we got. Now we have an issue, right? What's our issue? We have a fraction. And what do we know about fractions? Denominators can't be 0. So x squared minus 2 cannot be 0. Which means x squared cannot be 2. And x cannot be plus or minus the square root of 2. Now you put these two together to get your final answer. The domain of the final answer, you gotta put these two together. So you've got everything, and then you've got everything except these two things, plus or minus root 2. So when you put that together, it's everything except plus or minus root 2. Does that make sense to you? You're putting them together. Let's suppose for a minute this one had been, x can't be 5. So that's everything but 5. This one's everything except plus or minus root 2. What would the final answer be? Everything except 5 and plus or minus root 2, you put them together. All right, one more. We're going to do the same thing now, but we're going in the opposite direction. All right, so we're going to do g of f of x. So f of x is 1 over x minus 2. That's what f of x is in this case. So I'm going to do 1 over x minus 2. All right, now what does the g function do? The g function takes that and squares it. So that would be 1 over x minus 2 squared. Would you agree with that? And you can FOIL that out if you want, but you don't need to. What's the domain of the input function? That would be f. Here's f. What's the domain of f? X cannot equal 2. So everything except 2 would be absolutely fine in this function. It has a fraction. Denominators can't be 0. So x can't be 2. Now look at this guy. What's his domain? Everything except 2. So what is the domain of the final composition then? Everything. They happen to match this time. Often they do, often they don't. You just don't know. X can't be 2. Everything except 2. All right. One more thing. Get your calculators out if you have them.
So I have a question though with the g of f of x. Since your g was since your f was an x squared, would you take and technically square root the whole entire function, or would it just be the x minus 2 as the square root?
What? Okay. Why would you square root it?
Because of wasn't g x squared?
Yes.
So whenever you go from 1 over x minus 2, and you have to add g into that.
Okay, no. G squared. It didn't square root. It's squared.
Oh yeah, squared.
So that's why I have that. If it had square rooted, I would have the whole thing x minus 2 under a radical.
Okay.
But g was not, it did not square root it square. All right, so it's going to be our last, we're going to have to continue this next time, but here we go. Calculators out, Windows set, -10 to 10 on the x's and the y's. Just -10 to 10 for x min, x max, y min, y max. Okay? Everything else should be okay. Now suppose I said to you, we're going to sketch this equation. You would say to me, I can't do that. Because when I press, like if I want to graph something, how do I put it, what button do I press to put in an equation? Y equals. I have no button that says x equals. I have a y equals button. So if I want to put this into my calculator, what am I going to have to do? But, like always, when we square root both sides, we're going to get plus or minus root x. So to graph this on your calculator, you're going to graph root x. So one equation is going to be y equals root x, and the other equation is going to be y equals negative root x. Now, graph both of those, put both those equations in, and hit graph. You put the negative before the root. I'm sure it's because of operator error. So you want -10 to 10 on your y and axis. Okay, what did you get, kids, when you graphed both of these? What did you get? You got a sideways parabola. You got this. Now, what you just did is a huge concept in calculus. What you just did is take the original problem and you broke it very easily. This made sense to everybody. Nobody's confused by this. You broke it into what are called its implicit functions. Now, what that means is the original curve was not graphable on your calculator. You could not put this into your calculator because it is not a function. But implied in that equation are two things that are functions. Is that a function? Is this a function? So you took the big thing and you broke it down into two equations, each of which is a function, and when you put them together, you got your original thing. So, we'll talk more about this, but just for now, recap real quick. If I want implicit functions, what does that really mean I have to do if I want solve for y? That's it. You just get y by itself. Because as soon as you can get y by itself, you can put it in your calculator, right? Okay, have a wonderful day. Again, I'm looking at homework due on Friday and a test on Monday.
Do we do homework on Monday?
You'll have review work, I'll give you some review work. You already have it actually. This will be due on Friday. So I wouldn't start with this tomorrow, so I anticipate that you're going to be I absolutely will. Why? You're not going to be. I'm going to have a college visit. Oh, when did this fall down?
I think just now.
Okay, just now? Thank God.